rearrangement reaction. So in the previous three videos, we had discussed about the substitution reaction, elimination reactions, and addition reaction. So today, the last type of reaction, that is rearrangement reaction, we'll discuss. So by the way, I'm Pias Ghosh. I completed my master's in 2014 and now currently working as a manager in ONGC, that is Oil and Natural Gas Corporation Limited. So let's start. So rearrangement reaction, this is a broad class of organic reactions where the carbon skeleton of a molecule is rearranged to give a structural isomer of the original molecule. So often a substituent moves from one atom to another atom in the same molecule. Generally the migrating group never leaves the molecule. So this is the definition. We will have several examples of rearrangement reactions. So there are basically 5 types of rearrangement reaction, that is rearrangement to electron deficient carbon, rearrangement to electron deficient nitrogen, rearrangement to electron deficient oxygen, and rearrangement to electron rich carbon, and aromatic rearrangement. So in this video we'll discuss about the first two types. And here almost 9 to 10 reactions are there. We'll discuss about that. This is the first type of reaction, first type of rearrangement reaction, that is Wagner Meerwein rearrangement. This is very common in alcohol. So where 1 degree alcohol is produced alkene as a product. So how it happens? It undergoes through basically through a carbocation intermediate. So you can see the reaction mechanism. So this is the alcohol first in presence of H plus, it will convert into a good leaving group, and then the H2O, one molecule of H2 will be removed and a carbocation will be formed, and this 2 degree carbocation will rearrange to more stable 3 degree carbocation, and after followed by 1 proton elimination gives the alkene, that is gives the more substituted alkene. So this is Wagner Meerwein rearrangement. If you have any doubt about this mechanism, please let me know in comment box. Next, Pinacol rearrangement. So Pinacol, when 1,2-diol is called Pinacol. So Pinacol in presence of H plus gives a ketone, pinacolone. So this is Pinacol-pinacolone rearrangement. In presence of H plus, in the same way, it will convert a good leaving group, and if there is one OH group in the vicinity carbon, it will give the ketone, that is called Pinacol-pinacolone rearrangement. Now this is Benzilic acid rearrangement. So this in this reaction 1,2-diketone converted into alpha hydroxycarboxylic acid using an benzilic using a base. This is called Benzilic acid rearrangement. So in this reaction, the OH minus will attack the electron deficient carbon, and it will give a tetrahedral intermediate, followed by the formation of CO bond and a migration of one aromatic group to the next carbon, and this will convert into carboxylic acid group. This is very simple mechanism. If you have any doubt about this mechanism, please let me know. This is Benzilic acid rearrangement. Next is Arned-Eistert homologation reaction. So this is very important reaction to increase one carbon atom in carboxylic compound. That is the next homolog you can prepare by this reaction. So in this reaction, the carboxylic acid is first react with SOCl2, then it will convert it to aryl RCOCl, then acyl chloride, and after that it will react with CH2N2. CH2N2, then it will convert it into one N2 group, that is azide group will be. It will convert into azide group, and in presence of Ag2H2O, it will rearranged to give the next homologation. And there is some mechanism in this conversion. But if you have any doubt about, if you have any question, if you want to know about this mechanism, then please let me know in comment box. I will discuss this in detail. Next, Hofmann rearrangement. So in Hofmann rearrangement, one amide is converted into an amine in presence of Br2 and alkali, that is base. So the amide, the mechanism from that amide group, which group will take one proton, and then one substitution reaction will take place. So each will be substituted by Br, and this from this intermediate, again one OH, one alcohol will take the proton and will form the corresponding base, and then Br will leave and one isocyanide intermediate will be formed, which in presence of H2O, one CO2 will be removed and the corresponding amine will be formed. This is Hofmann rearrangement. Again, if you have any question about this mechanism, if you want to know more detail about this mechanism, please let me know in comment box. Next, this is the Lossen rearrangement. This is Hofmann, Lossen, Schmidt, and Beckmann. This type of rearrangement reaction follow almost the same mechanism. So here, conversion of a hydroxamic acid to an isocyanate via the formation of an intermediate. So the isocyanate can be used further to generate amine in the presence of H2. So this isocyanate will give the amine. So how this is happening? First, which will attack this proton will be taken by the alkali by this OH group, and then a rearrangement will take place. That is 1,2 shift of R from C to N, and will give an isocyanate intermediate. After that, H2 will attack and it will give the corresponding one CO2 group will be removed and the corresponding amine will be formed. This mechanism is similar to the previous mechanism, that is Hofmann reaction. Hofmann rearrangement. Now, next I will come to the Curtius rearrangement. So the Curtius rearrangement, acyl azide will convert to an isocyanate, which again react with H2O to form the amine. This is similar type of reaction only. So here acyl azide will convert it to an isocyanate. The isocyanate will react with H2O to give the corresponding amine. Again, similar type of reaction. Next, the Schmidt rearrangement. In Schmidt rearrangement reaction, it will produce The reaction is closely related to Curtius reaction except that the acyl agent is produced by the reaction of carboxylic acid with hydrazoic acid. So here the carboxylic acid will react with hydrazoic acid to produce the acyl azide, and which successively will react with will convert it into a nitrogen intermediate, and after that it will convert it to the amine with reaction with H2O. So if you have any doubt, any question about this mechanism, please let me know. We will discuss it detail. Just give a comment. Now Beckmann rearrangement. This Beckmann rearrangement is like in presence of the oxime will converted into an amide in presence of acid catalyst, and oxime. This is oxime which react with H2SO4 to give the amide. So mechanism is it will convert the which will protonated and it will convert into a good leaving group. After that, the group which is trans to the OH group will migrate to the nitrogen, and an N-alkyl nitrogen species will be formed, which will be stabilized by its structure. Then H2 will attack, and the corresponding amide will be formed through tautomerization reaction. So in this video, we had discussed the this type of reactions, and in the next video we'll cover the other type of rearrangement reaction. So guys, thank you. Have a good day.